Soldering. What is soldering? Soldering is using some type of metal to melt and connect other pieces of metal. So similarly to welding, we're connecting metal, but with welding, we are taking two pieces of metal, melting both, and creating one unified piece of metal. With soldering, we're taking one type of metal, maybe copper, like one might find inside of a conductive wire, and we are connecting it together using another metal. Historically, that would be done using lead, and nowadays we generally use something made of tin as the main component of an alloy. So we can connect wires by soldering, and when we do so, we want to be minimal with how much solder we're using, because when we add solder, it's going to create a very stiff area, and that stiff area is going to focus force onto the flexible conductors in our wires. Because soldering is not just an electrical connection, it's also a mechanical connection. This is something we need to be careful of. So that's why I've drawn this connection with the wires oriented in this fashion, as opposed to what you might think where you can twist two wires together like this. Remember, if we have force that's pulling apart, that's going to create a ripping force right here versus this shearing force, where the force is in line with the shape of our material. So this is a little bit more likely to stay in good shape. Now, like I said, we want to be minimal, both because we don't want an extra big globby thing to help focus force. We also want to keep things slim so that they don't potentially touch other electrical components. So looking at this in cross-section, if we have our two wire conductors right next to each other, when we apply solder, we want it to wet the entire surface and just be as minimal a layer as possible, where we can still see that the surface tension of the solder has pulled it into a shape like this, but we have a nice solid connection with no gaps and no breaks. Soldering wires together isn't the only use of solder. We might have a pad on a printed circuit board, such as this, where we need to solder a pin that comes through. And in this case, once again, we want to be minimal with our application of solder. We want to have enough where we're going to cover this completely, but not where it gets all big and globby. We want it to kind of look like a Hershey's Kiss. So just in full profile, if we have our board and our pin coming through, we want a nice Hershey's Kiss where we can still see that surface tension is pulling the solder into this shape and we're not getting a big globby mess. There are a few tools that come into play when we're soldering, the first of which is our soldering iron. There's many different kinds of soldering irons. There's ones that have external power supplies, one that plug it directly into the wall, and some that you can use with batteries. Next up, we have our solder. And this solder wire is a low melting point alloy that we're going to use to melt and make this electromechanical connection. Next, one thing that might come into play is a helping hand or a third hand. And so this device has these little clips that can hold electrical components in position for us, because while our solder is molten, we don't want it to be moving around too much. We want it to be nice and still when we're creating our soldered connection. Now, these are a little bulky, and if you do need to solder on the go, one thing that can be helpful is to get a pair of hemostats. Now, these are a surgical tool used to clamp off arteries or veins during surgery, but because they have this locking mechanism, they can do a pretty good job of holding on to components for you. All right, so let's do some soldering. If you have a wire that you need to expose the conductor of, you can use a pair of wire cutters or wire strippers to cut off any ends and use these scalloped bits which match up to the size of wire you might be using to remove a small amount of insulative material. I'm just going to solder directly onto the leads of these jumper wires. And what I'm going to do is I'm going to solder on an LED along with a 220 ohm resistor to limit the current that's going to flow through that LED. So first thing, I'm going to cut my leads of my resistor a little shorter. And I will grab in my other clip here on there, and I'll just align my two components as best as I can. And these clips have a little bit of wiggle to them, but our components also have a little bit of bend to them. So that looks pretty good to me. Now, just out of frame, I'm going to turn on my soldering iron. And I have this set to about 700-ish degrees. I personally like to run my soldering iron a little hotter than necessary. It just makes my life a little easier. So we have our soldering iron that's currently heating up. And if we look, there's a little bit of gloppy goop, melted solder from previous work going on here. So I don't know if my soldering iron is hot enough, but once it is, I'm going to clean the tip off using this moistened sponge. There's also certain tip cleaning tools like this that have basically like a Brillo pad inside. But for this application, I'm just going to use this sponge. So my soldering iron has reached temperature, so I can clean it off. And now we can see that's much more nice and clean. So what we're going to do now is I'm going to take my soldering iron and some solder in my other hand. And you see, this is where the helping hand really comes in handy, haha, because I have run out of hands to hold things in. Now, when we solder, let me zoom in, we want to use the soldering iron to heat up the work. This is the work, and we're going to use the work to melt our soldering wire. So I'm going to come in here, I'm going to come in and touch those components with my soldering iron first, and right where they meet, that's where I'm going to try to get my solder. We're not using the soldering iron to melt our solder and then like try to smear it on, right? It's all of these components are in play at once. And so that's not the most beautiful solder joint, but it is totally good enough. And so now I'm just going to clean the tip off that's out of frame and put my soldering iron back into its holder. And now let's attach our wires here. So now I can unclip my resistor from this side, clip one wire in, and realign. I need to do some adjustment here. Realign so that I can line up these other components. There we go. That looks good to me. And now, once again, make sure my tip of my soldering iron is clean. Come in here, warm the work with the soldering iron. Wait a moment, and then touch the solder in. Oop, that was a little bit of a miss, but that's okay. And there we go. Now that is connected. And so part of the reason that I say to not like twist the wires together is because sometimes you want to undo a solder joint. So for example, if I wanted to undo this, I would heat this, and once it's hot, then I can just pull it apart. If my wires were twisted together, that would be far more difficult because I would be trying to mechanically untangle some metal that is hundreds of degrees, which is no fun. So let's just get our other wire put on there. So I'll grab on there, bring these together. And one thing that can help this process, especially if you're dealing with larger components, is to preemptively tin the surface. And that by tin, I mean I'm going to melt solder onto the metal before I try to join them together. But these are small enough where I don't really have to do that. So I can just come in here, warm it up. I got a little bit spread out, so I might readjust here. Oh, yeah, that didn't go quite as planned. So I'm just going to reconfigure there, and I'll give that another try. There we go, that'll do. And so I'll clean the tip off, put my soldering iron in the stand, and now this is successfully soldered together. Now, I might want to take a piece of heat shrink insulation and thread it over to cover up some of that conductor, but I'm not going to use up this piece right now. And in some applications, you need to put the heat shrink insulation on first in case there's a plug or something on this end that you're not going to be able to fit it past. Okay, so now let's do a quick demo with our board. So you can take your board, and sometimes depending on what you're soldering, you can use a breadboard to hold everything in place. I'm just going to use my helping hand here, and I'm going to grab onto a pin here, a header pin. Get that in frame. So I have a little header pin right here. I'm going to get that aligned, and I'll line up my board and slip the pin through one of these perforations in this perf board. And I'll just get everything lined up nicely. This is not a standard operation to just do one pin in here, but I just wanted to do something that is easily removable, that I can demonstrate the shape that we want to get here. So once again, clean the tip. And now I'm going to come in here, touch the soldering iron to the work, and wait a moment for it to heat up. And then right where all of these things meet, I'm going to bring that solder in and just be patient. Oops. There, I missed a little bit, but that turned out okay. Okay, and so now if I rotate this and change my focus, hopefully, maybe you can see there that we have a nice, well, it's not perfect, it's a little crooked, but that Hershey's Kiss shape is what we want. Now, like I said, I wouldn't be normally soldering just one pin into this, but I just didn't have any components at the ready that made sense to solder a full pin header into. So that actually brings me to the next good demo that we can do, which is we are gonna desolder this. So the first thing that we can do, I'm gonna get back in focus. All right, so there's my solder joint right here, and I want to get rid of that. So using this here, which is solder wick, or also known as desoldering braid. And so this is going to use capillary action to suck up the solder. It'll soak it up just like a candle wick soaks up wax. There we go. So you can see that I have soaked up some of that solder with my solder wick. And so now there's much less solder in there. So now I'll clean my soldering iron off again. I might grab onto this pin with pliers, and now when I apply heat, once it warms up, that'll just slide right out. There we go. And so now I've gotten my pin out, but I have some goopy solder in there. Enter another soldering tool. This is the solder sucker. So this uses a spring-loaded pump to slurp the solder out of a perforation in a board. So now my solder is right here, and what I'm going to do is I'm going to heat that solder up on one side of the board, and I'll wait for that to get nice and toasty, and I'll line up there and slurp. And so that spring went into action, and now I no longer have any solder blocking any of my perforations. Have fun and happy soldering!